And now I can show you how to automatically do the cell type classification using support vector machines. We can do that using the Strauss 2021 Arabidopsis Gynoecium dataset. And we can run this file, Gynoecium01 final. So support vector machines are an established machine learning technique for the classification of data points. And this is new for MorphoGraphX 2.0, and it uses an interface with the lib.svm C++ library. And so first we can run the process mesh cell types classification and select measures. And this opens a user interface with two lists. The left ones shows all the measure processes, so all the processes in the mesh heatmap measures folder, and the right one shows the existing attribute maps in the mesh. And clicking on a measure in the left table will compute its values for the mesh and create the associated attribute map. And so it creates an entry in the right table. And we can select few attributes like signal interior, geometry length minor axis, and we can run also area. And after creating all the heat maps, select the measures you want to use to separate the data in the right table of the GUI and hit OK. All the select attribute maps are loaded onto the mesh, and also this can be time consuming if you have a very big mesh. And so you can generate the attribute maps in advance by running heat map analysis, cell analysis 2D. Now that we have some attributes loaded, we need to provide the training data. So we need to assign parent labels to some representative cells as training data using mesh cell types classification B specify cell types. So this process is identical with the process mesh lineage tracking set parent and sets the parent label of selected cells to the specified value. So we can select vertex and select mesh cells. And one way to select the cells is to use select point in mesh tool or Alt+V here. And we can select some of the cells here and then run selection extend to whole cells here. And remember, when you run this process, specify the label, so something like 1. Now you can set parents, so you can see that these cells are labeled. Now select another cell type, like here you can select a few of them. Remember to keep pressed shift when you select more cells, otherwise the selection will not be saved. Okay. Now we can extend to whole cells for this one. Selection, extend to whole cells. We can specify the cell type as 2. And also try to get some more cells maybe here. Okay. And now we can select some stomata. And assign the label as 3. So now in this example we have some cells here labeled in green, and this is the replum. Then we have the pavement cells labeled in blue and the stomata in yellow. And now we need to create a text file that will be used for the SVM training by the libSVM library. We can do that using the process mesh cell types classification C write training data. And we can give it a name like training, save. And this process is used to create a training data file which can be read by the library to generate and train an SVM model. It finds the cells with the parent label that is higher than 0 and their values of the selected measures and writes them to a file. And there is also an option to add the training data of the loaded mesh to an existing training data file. Here you can select it and append. And this is useful when the data from multiple meshes is written to a single training file. And then you can also run the training file augmentation. And so when there is not much training data available, when it's just few cells, or when the data is not very balanced, so some classes have only few cells and others many, the process mesh cell type classification detraining file augmentation can extend the existing data with artificial entries created from the real data with some added noise. We can select our file training. And so now we can train the SVM model using the process SVM train SVM model and selecting the training file from the file dialog. So training. And it is also possible to load previously created models using the process fload model, but you have to remember to create or load in advance the attribute maps used for this classification. And now we can classify the cells using the process mesh cell type classification SVM G classification. And here a classification threshold can be set, and only cells with a confidence value above the threshold will be classified. And to force the classification of all cells, you can set the threshold to 0. And now we can run the process. Okay. And then you can double check if all the classification is correct. So we see that some stomata were wrongly classified, and we can just select the label here. And we can go with fill label. Okay. And of course, if you use more attribute maps, then it will be easier, the classification, as there will be more information to classify them. In this case, stomata were classified using the signal intensity, the interior signal intensity, so it's a good attribute for stomata. But then when you have like different sizes, you can use area as well, or if only specific cells are elongated. Okay. Now the classification is complete.